everybody. Today we are going to talk to Luka Matic, a Croatian engineer who has a great interest in secure communications. Let's see if we can get him on Skype. Great music. Yes, there he is. Hi, Luka.
Hello.
How are you doing?
Oh, I'm okay.
Okay. So as I just said right before we called you, you are an engineer and you have a great interest in secure communications. And so in this interview, we are going to talk a little bit about that. But
All
first, before we start, can you tell us a little bit about yourself?
All right. So I'm an electronic engineer from Rijeka, Croatia. I was born in Rijeka. By the way, Rijeka is home of the first torpedo factory in the world and Naval Research Center. Everything was there, research, development, and production. Nowadays, there is not much job left there, so I had to go elsewhere. So my daytime job is maintenance of electronic systems on oil drilling rigs. I graduated in Zagreb on FAIR faculty of electrical engineering and computing. Okay, so I have a master engineer degree in automation engineering branch. So now I am 43 years old. This is what you can see around me is my home lab. I live here, my wife and my cat. In cooperation with Elektor magazine, I am working on some devices. This cooperation is going on fine.
And how do you know Elektor?
All right, so I didn't know about Elektor while studying at my faculty, but when I got my first job, this was a small company, and the owner of the company, who was also a graduate of my faculty, and he was a subscriber to Elektor. He had been a subscriber for a long time, so he proposed me to make a subscription. This is what I did. Then I started reading Elektor. Then I started making projects with Elektor. That's it. And one more thing, this man also spent some time during the 1990s war in ex-Yugoslavia. He spent some time in an army base, so he worked with electronics and he spoke about security. So this is also how I got interested in security systems and everything related to this.
So you have published several projects in Elektor magazine. Eh? Your last two projects, it's already already a while ago, was a true random number generator, totally analog, nice design. And then you did a one-time pad crypto system that uses the random number generator. And now you are working on a system to send SD cards securely through land mail to someone else. So this is all secure communications, etc. Where does this interest in security come from? You already mentioned the war you had in Yugoslavia and the dictatorships. Have people been spying on you?
All right, so this about spying, we will need to first redefine the term, but I will tell about this later. Yes, I was born in Yugoslavia, 1976. This was a communist dictatorship that lasted until 1990. Then finally, before the war, actually, we got first democratic elections. We thought things would get better, but then we get another dictatorship until 1999. So growing up in two dictatorships actually makes you start thinking about your safety and security from time to time and everything. When we talk about spying in the terms of 20th century and spying in the terms of 21st century are two different things. Speaking about electronic spying and surveillance, okay. In 20th century, electronic spying was actually required a team of people. The tape recorder somehow had to be connected to your landline, your phone line, okay, and then or maybe some electronic transmitter bug had to be planted inside your room somewhere, and a team of people had to follow you around. They had to replace those tapes in the tape recorders and everything. So once they started electronically surveying you, were practically already in the trouble. So this is so speaking about this kind of surveillance. I don't think that I have ever been spied on. I've never been politically active, never had any problems with police. There are two nice movies and TV series you can watch if you want to get acquainted with this. One of them is about East Germany, who was actually very high-tech for this time. Their methods were very high-tech electronic methods. Name of the movie is Das Leben der Anderen, or translated to English it would be something like Other People's Lives, or something like this. Okay, this is East Germany in 1980s. So the methods of surveillance from this time are very well described there. The other movie is series The Americans, about Russian spies operating in United States in 1980s. Also you can see very high-tech methods of surveillance for this time. But in the 21st century, everything changed. So many countries have already passed the law that all the telecom operators need to record all the conversations and keep them safely stored on their hard disks. And their obligation by the law is to keep them stored for at least 1 year, and they have to do it at their own expense. So this is at least the law that we have in Croatia. I think that all the European Union countries have almost some laws that are similar to this or something. So if we are talking about 21st century, yes, I have been spied on, but the same as everybody else. So all of our telephone conversations are recorded somewhere, and it is a question. Maybe somebody will review them, maybe somebody won't. So this is the situation in 21st century, yes.
Okay, I'm recording this as well, so this will be stored. So be careful what you say.
Yeah.
Before we continue, I think we have to make some vocabulary clear about Bob and Alice. Usually in secure communications, there are 4 people involved: Bob, Alice, Eve, and Mallory. Can you explain their roles?
Okay, so this is these are the usual names that we use, some crypto characters, names that we use to explain certain situations that can happen in terms of secure communications, spying, intercepting communications, and everything. So Alice and Bob are usually 2 good guys. They want to communicate, and they want to keep their communication in secret. So then we have evil Eve, the eavesdropper. She is a passive spy. She will try to intercept communications. She will try to crack their codes, locate their positions on everything, but she operates in a passive manner. Okay, and then we have Mallory, the active malicious spy. She can try anything else. She can try actively stealing their codes. She can try kidnapping somebody. She can try planting false messages in their communications to trick somebody, or everything else. You can check Wikipedia. There are more than 20 characters, I think, defined for when you analyze some complex situations. But to present what we have, if enough is to talk about Alice, Bob, Eve, and Mallory. So you just remember what they do in our some fictitious setup.
Okay, so let's consider us as Alice and Bob. Then we have to protect ourselves against Eve and Mallory. Do you think that I would need such a protection, such a system? Of course, we are being spied on by Google.
Yes, sure. This is difficult to say. So maybe at first somebody will say only spies and diplomats and maybe criminals or politicians may need this. But to analyze who could actually need it, maybe we just go a little bit back in past. Let's say less than 100 years. Okay, so the activities. Many activities that in a normal democratic society are considered legal. In case that you quickly switch to a dictatorship, they might become illegal, and your records are kept somewhere. Even in the previous century, okay, the records of somebody's activities were maybe kept on paper, but they were also kept somewhere. So, okay, let's say 1930s, an invasion by some Nazi dictatorship may still have seemed a long shot. How can something happen? Okay, there were some crazy guys in Italy or in Germany, Nazi parties, fascist parties, but nobody could actually predict this. But only in 1940 it became pretty much a realistic scenario for whole of the Europe. Okay, so this was the World War II, and then we had the Cold War, and some possibility that Soviet communists could invade the rest of the West Europe, okay, and everything, and even England was also for at least for today's point of view, this may seem like that something like this is impossible. Come on, are you crazy? What you are thinking about? But in 1980s, this was still considered as a possibility. Okay, so I just wanted to watch the Elektor historic cryptography video, a very nice video, and pay attention to last 5 minutes. There you will see a very nice, people talking about a very nice radio teletype system, encrypted radio teletype system, designed and produced by Telefunken. Okay. And the idea of the design was to enable communication without repeaters, land-based or satellite-based repeaters for several thousand kilometers. It was designed that it can be operated by unskilled operators who don't necessarily have to be educated radio amateurs or engineers. Okay. The idea was that this system would be used by guerrilla armies of Western Europe. This seems like impossible, but the project was initiated, and this was the scenario that was being worked out over and over. And these radio systems were actually produced up to a level of product, not only a prototype. You might need it or not, but the point is that in these things you need to think up front, because it is very possible that once you realize what you have done, what kind of information you have left somewhere, it may be too late.
Yes, you have to be paranoid to develop secure communication. You have to get into the head of a spy and try to come up with solutions to counteract that.
Yeah.
Okay, so of course spying we all know, we have seen it in movies, etc., and with technology. But what are the security risks of modern technology that we don't easily think about?
Right, so I mentioned 2 movies that are actually very good. Those are not some cheap James Bond stuff, and those are 2 movies that you should definitely watch if you want to get acquainted with this area. And speaking about this, I would like to point our readers to this book, Dictionary of Espionage, which covers all the important spying events from World War II and Cold War up to year 1985. Okay, so just to see how complex the subject is. People today are simply not aware of real problems. Even people from community of electronic engineers and programmers, and many people first of all think that there is no point in working on any design, on a design of new electronic devices. You can buy everything cheap from Chinese, everything is designed already, everything is invented already, so why should you bother designing anything? And the problem is that in terms of electronic security, this already formed mindset on vast majority of people, this thinking in a way of idiot-proof electronics, ready to use, plug and play, off the shelf, cheap from China, out of the box, readily made. This will not simply work here, because the main problem is that today when you buy a simple electronic device, it is very complex inside. People don't know what is inside. People don't know what this electronic device actually does. So a system that is too complex to analyze, that you don't know how it works, simply can't be secure for you. You must absolutely trust to the person who designed the system, and this is practically impossible. This you can't do. Today, for encryption, what people normally use, they usually use some general purpose PC or some smartphone or some specially designed cryptophone. All of those devices are very complex. You have no idea what's going on inside. They can be attacked in many different ways. If you simply want to buy a secure crypto system, you can't find something. You can't find something that is simple enough to analyze, that you can check operation and everything. So if you take a look at our article about one-time pad crypto system that we designed to make it simple, to make it open source, open hardware, so you can analyze everything, see what's going on inside, that you actually get some security in your hands. You will see a nice analysis, a very simple one that we made comparing a comparison between the German Enigma machine from 1940s and some general purpose PC or any crypto system available today, and it's easy to come to a conclusion that Enigma will beat them all in almost every security aspect except in mathematical strength of its code that can easily be broken today. Okay, but until 1943 it was mathematically impossible. Computers were not so fast and everything.
So if we resume, you say that secure communication today is difficult because the electronics we use is too complex. You have no idea what's going on inside, and this is why you design systems that are totally open source and open hardware, so you know exactly what is inside. You can analyze everything in detail, and you know what you are using.
Yes, and since we publish everything open source, then people from our community, people from Elektor Labs web pages, they can think of the ways how something can be improved. Because speaking about security, you can always improve something. I myself can not think of all the possible ways how to improve. So this is why any security device must be reviewed by a number of independent experts. And any one of them can discover something new and propose, hey, maybe this can be improved, maybe that can be improved. Yeah, this is it. This is the basic principle.
Okay. And so which ways of spying, let's call it that way, are you trying to counteract?
Spying is a very complex, very complex subject, and we are going to work on the problems of electronic security. Let's start first with method of encryption. First of all, we can use the code encryption method that is mathematically strong enough. Okay, I decided for one-time pad because this is mathematically simple and very simple to analyze and very simple to prove its power. Okay, and requirements are fairly simple. You need to have a good true random number generator to create a good one-time pad code that will be used. Other methods are mathematically more complex. If you are not a very good mathematician, you can't analyze it. I am not, so I decided for one-time pad. And the first thing I did was to design true random number generator. Okay, the generation of random numbers is a security critical process. If you do it on your general purpose PC, this can easily be spied on. This will not be secure enough. So I designed a small device, hardware device, okay, that will generate random numbers and immediately record them to SD card. So we will bypass the use of some PC or some insecure device. So this is the first thing I did, okay. So this will prevent stealing the one-time pads from a PC, and this will also prevent an attempt by Eve to regenerate the random number sequence, which can be done if you use some weak pseudo random number generator. Another method that Eve can use is to simply try to, could also be a better job for Mallory, to try to steal your plain text. Again, if you do it on a PC or some other general purpose device, some Trojan can leak your plain text outside. Then to communicate with one-time pad, the same as with any symmetric crypto system, somehow you need to, Alice and Bob need to exchange. They need to have the same one-time pad, okay. So to do this, okay, they can meet in private, but if they can't, they could use some paper mail, physical mail service, okay. We need to protect these one-time pads somehow, and this is why we are going to publish this safe, secure paper mailbox, okay. So using this box, putting your SD card inside will not protect you from Mallory opening the box and reading the contents of your SD card. But the box is designed as tamper evident, so it has a system to warn Bob. He receives it that the box has been opened somewhere along the way, and then simply this one-time pad will never be used. So Eve and Mallory will not get any useful information out of this. This is another way of spying, and we can also prevent it like this.
About Eve, who tries to eavesdrop on the communication, there's also something like Tempest.
Oh yes,
text.
yes.
Can you say something about that?
Yeah, sure. This is definitely something that is also overlooked today, mainly because many people don't know about this. So I would like to read this book. Bruce Schneier, Secrets and Lies. This is about electronic security in general. There is a chapter talking about Tempest attacks. So what is this? The problem is that all the electronic devices leak some kind of radio frequency energy. Tempest is about residual radiation present in all of the devices that is simply there because of the physics of those devices. So the first Tempest attack recorded is the history is, as far as I know, was the First World War, the Battle of Verdun, and what happened was the following. This was a German army retreated from a trench, so this was World War I, trench warfare, very long trenches dug in the ground, which is important for what happened later. And so when French advanced and when they took over the trench, they put their wired field telephone cable inside the trench. And what they didn't know was that the German cable was still there. So those cables were very close to each other. Of course, the frequency carried through those cables was the human voice audio frequency up to 3 kilohertz, but the length was very long. So at very long length of more than a kilometer or more, there you can create RF radiation strong enough on a distance of less than 1 meter that can induce some voltage in the other cable. So when French started talking on their field telephone, the Germans all of a sudden picked up some signals on their old cable, and when they put a good audio amplifier, which was available at this time, the audio tube amplifier was available. Okay, they could actually listen to conversations from the French side, and so this was once again, this cable was not intentionally put close to that cable. This was not a device from the beginning designed to. The system was not designed by design to spy on the other phone system, but just because of the leakage from a pair of wires, it was possible to pick the signals. And the other very famous event was mid-1980s. Wim van Eyck from the Netherlands. He discovered that every cathode ray tube monitor actually radiates some RF power. I'm not talking about TV receivers here that have their super heterodyne oscillators inside that radiate power. No, and UHF range. I'm not talking about this. I'm just talking about visual display, visual display units. This is what they called computer monitors at this time. So a computer monitor has a circuitry that works up to 6 megahertz, which is bandwidth of a normal analog TV signal, and the problem was that this residual radiation was not transmitted on the frequency this low. What he discovered is actually that it is present in some low UHF range up to several hundred megahertz. So what he discovered is that actually the box or metal parts, metal enclosures inside can behave as cavity resonators for UHF frequencies. You have some capacitance, you have some wires wound up inside that will behave like inductance. You have a source of power, and this can residually start behaving as a UHF oscillator. these monitors were behaving like UHF video transmitters, so up to several hundred meters of range with a good antenna, good amplifiers, good circuitry to recreate horizontal and vertical synchronization signals. He could actually pick the picture from the TV monitor, and this was at first this was thought like some theoretical research without no practical value, but when he proved that he can actually read a picture from your computer monitor, then this caused start causing a lot of trouble. It started a lot of trouble for the security because every computer monitor all of a sudden became a UHF TV transmitter. So after this, many other methods were discovered. You can Google it up on the internet. You can find on YouTube a method for Tempest eavesdropping on normal PS2 keyboards. In a keyboard, you have a keyboard controller, which is a microcontroller. Your PS2 is an asymmetrical line, which will not draw the same power when transmitting digital 1 or digital 0. And if it changes just a little bit the amplitude of oscillation of the clock generator for this controller, this clock maybe works at some 20 megahertz, it will start behaving like the shortwave amplitude modulated transmitter, and this signal can be picked. So protection against Tempest attacks is very difficult. Shielding is usually not good enough because nowadays devices, they can transmit residual radiation at a very wide span of frequencies. What is a little bit more effective is transmitting some small jamming signals. So first, you need a good spectrum analyzer to see where in which frequency spans you have this residual radiation, and then transmitting some false signals of very low power at the same frequencies, but higher power than your device that you're trying to protect. This is a way to protect, but those protections are usually very expensive, and the point is that nobody takes enough care about this.
Yes, that's always the problem, of course, in security, is the human is the weakest link.
Weakest link, definitely, yes.
So you use slow communication between devices. That helps against Tempest. If you slow down the edges, that helps even more.
That's
okay,
yes.
But you also used to try to use or you reuse, let's put it that way, old technology. Yet we have super high-tech stuff, and yet you prefer to use all this old stuff. So why is that?
Nowadays, high-tech microcontrollers or FPGAs, their level of integration is too high, and you don't know what is inside. This is one of the main problems. But there are also other problems that systems are actually much worse than the old systems. So let's make a comparison. Let's make a comparison of some new and old memory technologies. Okay, the oldest one, which is pen and paper. Then, as we advance through time, at some point in time, we got cassette tapes, we got analog movie tapes, analog film tapes, sorry, for analog photography. So then we moved from analog to digital world. So we got floppy disks. Then we got this ultraviolet erasable EEPROM chips written by electrical signals, erased by ultraviolet light. Okay. Then we got hard disk drives, first with direct cylinder head sector addressing. Then they switched to logic block addressing, which is similar to solid state technology. And at the end, we got flash memory, which is a solid state device, which is used in SD cards, in USB pen drives, in SSD drives, everything else, and including also the microcontroller units. Okay, every one of them has a portion of flash memory, which is written by electrical signals, erased by electrical signals, and can be even altered during the run. Okay. So what everybody knows is that as we advance through time, the costs of the memory per 1 megabyte, or maybe costs or level of integration, how much memory you get per square centimeters. Okay, this everything increases, prices go down. Okay, so everything looks perfect. But if you analyze, the technologies from the standpoint of security, you get a paradox. Security is actually decreasing as you advance the technology. Security is decreasing, and flash memory is actually a nightmare from the standpoint of security. So there are two things we should compare now. First, this is the reliability of long-term data storage. If you store some secure data, you want to keep it there securely. And another point we need to review is the possibility of controlling the writing and erasing process. This is important, and if you put something, some critical data, you also want to be able to quickly and securely destroy the data of this device. So, speaking about long-term data storage reliability, let's start with pen and paper, and we see pen and paper, if properly stored, can keep the data for 1,000 years or more. So actually, pen and paper is the most reliable method. Cassette tapes, they can keep the data for more than 30 years, longer. Analog film tape can last for 50 years or longer, maybe 100 years. Okay, so analog film was also used in form of microfilm to store large amount of data. Ultraviolet EEPROM memory chip, they can be reliable for some 25 years. Okay, after this they need to be replaced. And even hard disk drive and solid state flash memory drives, those are even less reliable. Shouldn't trust them for more than 10 years or even less. Okay. And this possibility of controlling writing process and possibility of securely destroying the data starts from pen and paper. With paper you have no problems. You can use a lighter, you can quickly burn it, you can dip it in acid, can eat it, and this will surely destroy the data carrier with absolutely no possibility of data recovery. And on paper, which is very important, you don't have any secret sectors. Magnetic tapes, the analog film tape, here we have almost the same. Very good situation, actually. There is absolutely no secret sector. You know, on a magnetic tape, when you write on it, you know exactly on which centimeter of the tape you wrote what you wrote. If you want to destroy them, you can easily burn them, and you can even more easily destroy them with some strong solvent, acetone or something, so without even increasing temperature and lighting a match. If this is dangerous, this will solve the problem even more easily. Okay, very good from the standpoint of security. Speaking about EEPROM memory, since EEPROM is erased by ultraviolet light, and you expose a whole area of the silicon die to ultraviolet light, there is absolutely no, or maybe very low possibility that some of these sectors can be hidden. So you simply expose whole area of the silicon die to the ultraviolet light. That's it. And the possibility of the data being modified in runtime, where there is almost no possibility, because you have special pin EEPROM for powering, a special pin for programming. This VPP pin needs some 13 or 14 volts. If you don't put 13 volts there, you can't change the program inside. This is important. When we get flash memory, we will see what is the difference. Okay, so destroying EEPROM chip is a little bit difficult, but wiping it with ultraviolet light is actually very simple. So from standpoint of security, this can still be used securely. Speaking about hard disk drive, well, if you use the old method, cylinder head sector, direct addressing of individual sectors, in this method you still had some control of where you actually read or write or erase. Modern day hard drives use logic block addressing, where you actually, as a user, use the ability to control this. You lose this ability, and then this is bad from the standpoint of security. If you want to erase a certain sector, well, you can't do it anymore. Speaking about destroying the data, okay, using delete command or everything else, if you don't have a control of which sector you read, write, and overwrite, you can't do it. But since this is a magnetic storage technology, heating it up to Curie temperature, where you lose the magnetic properties for steel. For steel or anything iron-based, it is about 250, 300 degrees centigrade. You can still do it safely inside your average kitchen oven. Okay, so there is some possibility of data recovery, but you can deal with this. Still, you can deal with this, but this is still definitely not a preferred method of storage from the security standpoint. And now, when we come to flash memory, solid state memory, this is what I like to call Alice's and Bob's nightmare, but the sweetest dreams of Eve and Mallory, because here you absolutely lose the ability to control which sector you read and write. And furthermore, any flash storage device has a lot of secret memory sectors that you can't access. This is not because some Mallory made a conspiracy with everybody else to put it. This is because the flash memory, by its physical properties, is not so reliable. Is much less reliable than a hard drive. So in the old days, when you went to format the hard drive, the system would mark the bad sectors. But this would be this you would do only once in solid state flash memory. This process is constantly repeated and controlled by internal microcontroller, because the sectors of flash memory, they tend to fail over time, and they are constantly dynamically replaced by fresh sectors. So this actually means that SD card that has a declared capacity of 8 gigabyte probably has more than 16 gigabyte of raw memory space inside. And you have absolutely no control of this space. When you erase something, when you give a command, the microcontroller unit of SD card will probably simply write another new data to some other space, and the old data will still remain inside. This is, you can check on Wikipedia, this is called write amplification, and this is very, very bad from security standpoint. And if you want, and since you can't erase this with UV light, and since anything can be modified in runtime, because for writing you need low voltage, you don't have any special pin like at the EEPROM, okay? The only way to securely destroy the data is to heating it up to 1300 degrees, which is very, very impractical. You will also find this information in blog. There is a security blog, you can easily Google it on the internet, by Mr. Bruce Schneier, where they discuss all the aspects of security. So they had a discussion about how to destroy flash memory data. So silicon will melt down in 1420 degrees. I think you don't need to reach this temperature, but you just need to start to break the crystal lattice structure, and this will happen at 1300. So for this, you would need a good blacksmith's furnace to reach this temperature, and this is very, very, very impractical.
So because of this, the way they organize flash RAM, etc., and microcontrollers have flash memory,
and everything integrated in one place.
Yes, yeah, exactly. So it would be easy for a manufacturer to add some secret memory to it that you don't know about, and use it for recording sensitive information.
Yeah, for manufacturer, even nowadays, if Eve and Mallory work for some not so, they don't even need to have a very, very large funds. What they can do is to take a blueprint of a silicon die of some already known microcontroller, or decapsulate one of them, okay, and then they can what they can do is to take the drawing of the silicon die, and they can simply add one more circuit, which will be designed as a hardware backdoor, which can take control or modify some data or record some data, okay, at certain point, and then this data can be secretly kept inside one of those secret flash sectors that are always there. And this is one possibility. This is one possibility how today's technology can easily be attacked, because even Mallory can produce their own chips, or they can let Chinese factory produce these chips. For example, we'll never ask them, what do you need this for? Well, who cares? Here is the drawing of the silicon die. Please make these chips for us, and then we will put a stamp on it, and we will mark them like Atmel Mega 328, and who will know what is inside? So this is one of the methods, and so as you can see, if you make a simple system with Z80 or 8501 or 6510, is it?
I'd used the 6502.
6502, yeah, okay, sorry, my mistake. So you did it yourself. So those are, if you make a simple system like this will be even cheaper today. So because there is a lot of this surplus hardware laying around eBay where you can buy it actually. Okay, so those were this technologies was proven to be successful. It has been manufactured in many pieces. So today price went down. You can still buy it. And if you make a system like this with a separated static RAM, with separated EEPROM, this will be a lot more secure than what you make today inside some highly integrated microcontroller or FPGA or something. Yeah.
Still, wouldn't the most secure way be to simply send Alice to Bob and tell him in person the message?
Yes, and the most secure way for them nowadays would be to actually avoid talking, to write everything down on paper, because nowadays, because any cell phone can be spied on, any cell phone that you have in your pocket can actually record your conversation and transmit it later if it is infected by a virus or something. So this would be the most secure method, but
writing on paper.
Yeah.
There are cameras everywhere, so cameras can see what I write.
Cameras are also everywhere, but they are much more simple to detect than audio devices. So write it on a piece of paper is a kind of more secure. Okay, so humans are definitely the weakest link in any secure systems, and we can try to make better electronics, but we can't change humans. This is a job maybe for psychologists or somebody else. In this Bruce Schneier book, you will also find different situations when some crypto technology was put in place, but humans simply failed to use it correctly, or maybe he describes one event when they simply didn't want to use it. The simple employees of one company, they thought this is too complicated and they simply stopped using it. And this was when he came to review the state of security inside the company, he saw that people simply stopped using this because they thought that this is too much of a nuisance. So humans are definitely, humans are the weakest links, and you can also, for example, in this dictionary of espionage, you will find events from Cold War. For example, the most famous was Kim Philby, very high-ranking spy working for British intelligence, who was leaking information for Soviets for very long period of time until he got detected, and he then escaped to Soviet Union. So, for example, both him and all the humans are working around him were actually very weak link in this system in this event, and you couldn't using any kind of electronic technology, you couldn't do anything against this. So these are definitely other problems. Yeah.
Okay. If I want to learn more about secure communication, can you recommend some books?
Bruce Schneier, Secrets and Lies. This is about electronic security, computer security, network security. But he also talks about how these security systems must work together with humans and the physical security and all other things, all other aspects of security to make a truly secure system. And the other one is the Dictionary of Espionage. So
who is the writer?
Writers are Christopher Dobson and Ronald Payne.
Okay.
So this is this is description of many events and people involved in espionage of 20th century. This is on Cold War, and events are described where electronic systems were used and where they were not used, when the situations when actually were cracked or crypto analyzed or some equipment was stolen, anything. So this is a good book to see what you're dealing with in the security. And this is another book talking about retro audio technology. Okay, from Elektor. Author is Paul Hetrelezis. Sorry, I don't know how to pronounce correctly in German. So this is about retro audio, but retro audio technology, like cassette tape, can be used for a secure system. So if you intend to work with cassette tapes, this is a good. This has a very good chapter about cassette tape technology.
Okay. What can we expect from you in the future?
Right. So I have many plans actually. So this safe paper mailbox will be published in Elektor. Okay.
Yep.
So we made it secure using the microcontroller unit. Okay. So somebody will now ask, okay, so you have a highly insecure microcontroller. What are you going to do against the backdoors? So we will also publish another article with some possible add-ons, because we left enough space inside the box, that will be designed to counter the possible hardware vectors. They simply work in a way that to periodically copy the contents of your static RAM to these secret flash sectors. So they can do it discreetly. It is very difficult to detect their activity, and if somebody, for example, our paper mailbox and manages to read the contents of those secret sectors from the microcontroller that had been rigged by Mallory or somebody else, okay, to do this, then he can simply recreate the condition of static RAM and send the mailbox on its way after reading the SD card. So this is a danger. And there are those application-specific hardware vectors that work in a way that when they detect that the microcontroller unit is loaded with firmware for certain application, for example, for this paper mailbox, then they will actively change a part of the program or simply disable this protective action or something. Possibility of being attacked by this kind of vectors is actually very low, but it is still present. So as we have already said, you need to think up front, you need to think in advance, okay? And this can be, they can be prevented. They can be prevented by using some kind of obfuscated code inside the microcontroller firmware. This is actually one exception to the rule that everything should be open source and open hardware. Okay, open hardware definitely, but open source software, in this case, everybody who starts using it will have to modify the software. But again, made the software code open source, so you can more easily do it. And this will have to be modified in a way to conceal the real application of this firmware. Putting inside what we exactly the same code, exactly the same firmware that we will publish on our labs pages in our article, then makes no sense, because it will be easily detected. So you modify your code, make it more or like what they call obfuscate, some useless code, fill the rest of the flash memory space available with some useless codes to conceal the real purpose of the code from a hardware backdoor throw-in. And both of these vectors, both of these trojans can be, in case of paper mailbox, can be counteracted in a way to use some extra unrecoverable memory technology that we spoke about before. Okay, so if you use an analog film tape, and in case of tampering, you overexpose it with a strong LED, or with which is even better with this magnesium flash bulb, which can be triggered with very low voltage. This way, if Mallory does all the job perfectly, she will not be able to recover information from analog film tape, which is overexposed with very strong light. So this is an idea that we will work out. Then to complete this our crypto hardware series, we will need one more device, and this will be a secure device to securely copy from one SD card to another, and possibly to cassette tape. The problem is, if we use SD cards. For example, you take our crypto device and make offline encryption. Okay, so the point is, now your SD card has your encrypted file stored, everything is okay, but you don't know what happened to the plain text. Plain text will probably be inside some secret sector. And if you decide to mail this card by paper mail carrier, okay, but of course you can't mail this particular SD card. But first you will use this secure copy device that will copy this card to another card that has never been used for anything before, and this card will not have anything stored inside the secret sectors. So this device will copy only the encrypted version of the file, and this plain text will remain in secret sectors of the first card. But now you need to make a copy, because Alice and Bob need to have one copy each so they can communicate. So for this you will also use this copy device, which is the only secure way to copy the SD cards. You can't put this SD card with critical information inside some PC or smartphone or anything else. To make the copy, you need a special device. And of course, because of the security advantages of cassette tapes, I will try to make also a possibility of recording it on cassette tape. We will make one, we're planning actually to make one background article about Tempest, okay? And yeah, this is what you can expect. I have actually a lot of plans to do, because many things, as you can see, in the security technology is actually not available to everyone. Yeah.
Yeah, secure communication seems to be, as I hear you talk, like a large domain where an electronics enthusiast can eat his heart out. There's all sorts of things to do with old stuff and new stuff and try to get it working. It's very interesting. So I suggest to everybody to have a go at it. Is there something that you would like to say to our viewers?
One of the problems that I can see with electronic engineers today is that they're kind of getting depressed, because they'll say everything is invented, there is nothing new to invent. Well, here is what you can do about this. As you can see, many things can be done in electronic security area. So this area is widely open for research. Many new things can be invented, many things can be improved. You don't need a lot of money if you operate on DIY budget. As you can see, even old technology is even more secure. So it is still available. Those Z80s or 27C EEPROMs were produced in millions. You can buy them everywhere. So it is the technology that you need is easily available. You don't need some expensive or difficult to obtain or something else. So you can buy everything. You can do it on DIY budget. There is a lot of work that can be done. We have our Elektor Labs web pages where we can exchange our ideas. You can take a look at our project pages. Some of the people had good ideas. Some of them jumped to some conclusions very quickly. But as you can see, the discussion is actually very interesting. So we can always come to a new idea or something. For example, we had a through random number generator, and then one engineer from Munich, Matthias Wolf, he made a very nice improvement to display a live histogram on a monitor. So there is always something that can be improved, and there is always something new that can be designed. Yeah.
Yes, it's an excellent domain for hobbyists and enthusiasts to be creative and invent and come up with ideas, etc.
Yeah.
You need, of course, secure payments if you buy all your stuff on eBay. Yes, the internet, of course, is very unsecure, but that's for somebody else to work on.
Yes, definitely. Yeah, this internet by design was not designed to be a secure network. So security features were being implemented later. So this is also what Bruce Schneier's book talks about. Yeah, everything depends on internet, and the internet by itself is highly insecure, and many people are still not aware of this. Yes.
Yes, and so your devices are never connected to the internet.
Yes. This is what you can find in our articles, because I wanted to avoid connecting them to internet, or there is a possibility that our one-time pet crypto device can transmit to the internet, but then you first securely encrypt it, and then you put it on low bandwidth audio channel, okay, and then you can use some voice over IP software to transmit audio signal.
So then, when I listen to you, it's all about electronics and software, etc. But what if Bob or Alice, or either both of them, they don't know anything about all this? At some point, they have to trust someone to use it.
Yeah, definitely. This is what I said previously. Espionage is very complex thing. So Alice needs to know at least basics of electronics, so she can actually check on her device. Because if she received it from some other guy, either she can trust him or her 100%, or she has to check everything herself. So this is why espionage is so complex. One single guy, Alice or Bob, would need to be very good with electronics, with cryptography, with mathematics, with diplomacy, with psychology, with martial arts, with use of firearms, with everything, so he or she can operate securely by himself. So
yeah, it's a complicated subject.
It's complicated stuff, but this is the main problem. Somebody, if I design a device and I give it to you, you can check the design because you are also an electronic engineer. But if Alice doesn't know even basics of electronics, that she is in trouble if she wants to be a good spy. Yeah, that's it.
Yeah, at some point you have to put trust into the system.
Definitely, yeah.
Well, thank you very much, Luka Matic. Thank you for all this information. I thought it was very interesting, and I'm sure our viewers will think so too. I'm looking forward to finalize your temper evident mailbox and see it in Elektor magazine. And yeah, I wish you a lot of luck and pleasure and fun with developing these kinds of systems.
Good luck. I wish good luck to you as well to keep up the good work with Elektor, which is nowadays one of very few magazines where you can actually do what we do. So I hope you will keep up the good work with Elektor Labs web pages and everything else. Okay.
Okay, we will try. Okay, thank you. Bye bye.
Thank you. Bye, man. Bye.